All right, straight line motion. So essentially just a particle moving in a straight line. There are two ways that we are going to look at it. We are going to look at it as a movement on the x-axis, right? So that would mean a particle is traveling right, or it's traveling left, or it's going back and forth. Right, it's moving along the x-axis, or we could look at it as it is moving along the y-axis, going up and down, right? So if I'm going up, that is considered the positive direction. Going down is considered the negative. Going to the right, is the positive direction. Going to the negative, or the left, is the negative direction. So with all of these things, we've talked about these things kind of going forward. Velocity is the derivative of the position. So you don't necessarily need to be able to do all of this, but velocity is the derivative of position. And you need to make that relationship as you are going as well. Speed is just how fast you are going, so it's essentially just the absolute value of velocity. Acceleration is the second derivative of the position, the first derivative of the velocity. That is my acceleration. So with all of this, right, if my velocity is positive, right, if I'm talking about x, then I'm moving to the right. If it's negative, then I'm moving to the left. If a is greater than 0, then the velocity is increasing. If the acceleration is less than 0, it's decreasing. So here's where this gets into a little bit of a technicality. As long as acceleration and velocity are working together, so let's say velocity is positive, acceleration is positive, so I'm going in a positive direction and I'm accelerating even faster in that positive direction, then my speed is increasing. If they are working against one another, so say my velocity is positive but my acceleration is pulling it back down, then I should be slowing down. Or other way around. If my velocity is negative but I'm pushing it back up with my acceleration, then it should be slowing down. As far as like positive velocity but negative acceleration, think about if you throw something up, the Earth has a negative acceleration. It's negative 9.81 meters per second squared. So as I throw it up, it's decreasing the acceleration. But as I drop it, the acceleration is increasing, the speed is increasing as it falls to the earth with that negative velocity. Okay, for horizontal line, x is left and right. For y, it's up and down. But that's essentially it. So let's go ahead and start jumping in after this stuff. So a particle starts moving at time equals 0. So I have no negative time with this one, and moves along the x-axis such that its position at time greater than or equal to 0 is given by this function. Find the velocity at any time greater than 0. So AP test time, they want you to make the relationship that x prime of t is equal to v of t. You cannot just straight up say v of t. So the velocity would be the first derivative, so 3t squared minus 9t plus nothing, right? For what values of t is the particle moving left, so I need to have the velocity less than 0 for that. So if I make a number line, right, I need to figure out where the velocity is equal to 0. Well, the velocity is equal to 0 when I have 3t and t minus 3, right? So t equals 0 and t equals 3 is when I will have a 0 velocity. So if I put in 0, right, where my time starts, and I can probably actually chop off the left side of this number line, and I also have 3. Right, so anything between here, so I could have like 1 and test that. So here's my velocity, here's my position. So if I put in positive 1, this comes out negative, and if I put in positive 10, this comes out positive. So let's see, right? I am decreasing and I am increasing. So essentially I'm moving to the left between 0 and 3. So at times 0 to 3, because v of t is less than 0. Again, you have to have that justification. For which times is the particle moving, but the acceleration is 0? So let's see, my acceleration is the second derivative of the position which is the first derivative of the velocity, is my acceleration. They will also want to see that relationship. If you do not have this relationship, they may or may not award you points. I can't remember, but I know for sure you will at least lose 1 point. They have to see that relationship. I think it's just that you lose a point, but that's 1 point out of 9. Okay, so the acceleration would be 6t minus 9. So t equals 2/3, I'm just kidding, 3/2, is when I am equal to no acceleration. So, right, it's moving in a negative direction. It's moving to the left. I'm sorry, I keep doing it the wrong way. Moving to the left, right, but the acceleration is 0. So that is the time, because a of t is equal to 0 and v of t is negative, right? V of t is less than 0. So that tells me it's moving in a negative direction, but it has stopped accelerating for that moment. Okay, for what values of t is the particle speed decreasing? So it's going to be decreasing when the signs are working against each other. So let's think about that, right? If I think about how these interact with one another, for the acceleration, that's changing at 3/2, and I'm going to check from 0 on. So if I check anything less, if I put in 1 or something, this is going to come out negative. That means I am decelerating. If I come out bigger, that would be positive, so that means I'm accelerating. Right? And essentially my signs have to work together. So if I look at how I interact with my position function, sorry, not my position, my velocity, they have to have the same sign. So it looks like the speed needs to be decreasing. So they got to be working against each other, right? From 0 to 3/2, they are both negative. From 3/2 to 3, my velocity is negative, and my acceleration is positive. And then from 3 to infinity, they're both positive. So in these two instances right here, right there and right there, they are working together and accelerating. Here they're accelerating in the negative direction. They're going faster and faster in the negative direction. Here they're going faster and faster in the positive direction. So the times where they are decreasing, so speed is decreasing, at times 3/2 to 3, because v of t is less than 0 and a of t is greater than 0. All right, so that is your answer and that is your justification. Because they have opposite signs, the speed is decreasing. Okay, so after this, what I wanted to look at was a resource, academic decathlon team. All right, there it is, right there. Hang on, just one. All right, so particle moves along the x-axis such that any time t greater than 0. Let me make this a little bit bigger. I'm sorry. Make sure that's big enough for you guys to see. Go away, thumbnails. Nobody likes you. Nobody likes you. Nobody likes you. Okay, sorry. Had to do it. All right. Particle moves along this such that it is this function. What is the acceleration when t equals pi over 3? So let's see, right? X of t is equal to -1/2 cosine of t minus 3t. So x prime is +1/2 sine of t minus 3, and x double prime would be 1/2 cosine of t. Right, so really all that I am looking for is x double prime of pi over 3. Well, that would be 1/2 times cosine of pi over 3, which would also be 1/2, so this would be 1/4. So hopefully I have an option that is 1/4. Look at that. Magically. Alrighty. Point moves along the x-axis so that any time t, notice it does not tell me greater than 0, its position is given by this function. For what values of t is the particle at rest? So if it is at rest, that means there is no velocity. So I have x of t equals to root x ln of x. So x prime of t would be 1 over 2 root x ln of x plus root x over x for my derivative. I'm trying to figure out when this thing is equal to 0. So I'll get common denominators. I need to multiply by 2 root x on this first one. No, I'm sorry, just by root x, and the second one by 2. All right, so root x, and this one by just 2, to get a common denominator of 2x. So I will have root x ln of x plus 2 root x over 2x. So I know x cannot be equal to 0. Otherwise, that would be undefined. I'm just trying to see when it's equal to 0. So I have 0 equals root x times ln of x plus 2. Right? So root x equals 0. Well, that can't be because I cannot be equal to 0. Otherwise, it's undefined. So the only solution I would have would be ln of x plus 2. Well, that's where ln of x is equal to -2. So e to the -2 is equal to x. So x, I don't know why I'm writing all of these x's. Holy cow. Well, they gave it as x. That's why I'm writing it as x. That should have been t. They messed up. There's a typo. These should all be t's because it's x of t. So those should all be t's. Anyways, x, t, whatever, equals 1 over e squared is probably how they will have their answer, and it would be that one right there. Alrighty. Particle moves along the x-axis such that any time t, what is the velocity when the acceleration is 0? What's going on, Lucas Morgan?
Not much.
Let me not get you the Rona.
Oh, yeah.
Mrs. Rona.
Should I send it here?
It's wherever you want me. It doesn't matter. All right, folks. Let's see. This one looks like it is a calculator question. So I will use my calculator and only my calculator. Particle moves along the x-axis such that its position is given by this. What is the velocity when the acceleration is 0? So I first need to find when the acceleration is 0, and that is going to be, let's see, 3 sine t plus x squared plus 7. All right, I'm going to do the derivative of this. Of y1. Of y1 at x equals x. Right, so what I can do is y2 is my first derivative, so I can solve using my second derivative and see when the derivative of y2, right, when my acceleration at any value x is equal to 0, that is when x equals 0.729. So now all I want to do is y2 of that value x, and there is my answer, 3.696. Yay! All All right, two particles start at the origin, move along the x-axis. The respective positions are given by this. Oh, recognize that question? This was a question on your midterm, wasn't it? Yes, it was. So the only other thing that I gave you was like, I believe, for how many values of t do they have the same velocity? I just told you in the problem that the velocity is the first first derivative. So I gave you what you needed, but you guys have done that problem before. Particle moves along a line such that time t. What is the minimum acceleration of the particle on the interval? So this one's interesting, right? So it's talking about the minimum acceleration. So I will want to go to the second derivative, but I will also want to do the fourth derivative to figure out where that has a minimum. So let's get after it, right? So v of t is equal to negative t cubed. Well, I'm already given the velocity, so that's nice at least. All right, so then v prime of t is equal to my acceleration, which is negative 3t squared plus 12t minus 15. And I want to find when that has a minimum. So if I want to find when that has a minimum, the easiest thing to do would be my first derivative test. But I'm going to do the first derivative on the acceleration. So a prime of t would be negative 6t plus 12. That is equal to 0 when t equals 2. Right? And so if I do my derivative test around 2, if I plug in 0, that is a positive, so I'm increasing. And if I put in 10, that is a negative, so I'm decreasing. So going back to my answer, what is the minimum acceleration of the particle on that interval? So I need to check a of 0, I need to check a of 2, but really I don't because I know that's a maximum. But I need to check a of 5. So a of 0 would be 12. A of 2, just for the fun of it, well, that would be, oh, that's not 12. What are you doing? What are you doing? You're plugging in your acceleration function. I'm sorry. All right, so a of 0 is negative 15. A of 2 is, let's not use a calculator. Negative 12. Plus 24 is 12, minus 15 is negative 3. And then a of 5, I'm going to cheat and use a calculator on this one though. That is negative 30. So the minimum acceleration would be negative 30 on this interval, right? I'm given 0 to 5. Okay. We talked about how to do that. Talked about that. And we talked about that. Okay, so you should have gotten everything that you need in order to be successful with straight line motion. So from this point, you guys have in the drive right, under your homeworks, you have the straight line motion worksheet. It's going to be exactly what we've been talking about. It's nothing out of the book, but if you scroll down, you have your answers as well. And then there's a little review for you guys as well, just dealing with the derivative, the function and the first derivative and the relationships that they have together. But you guys have the key to that down here as well. All right, other than that, let me know what question you guys have, and I will talk to you all soon. Bye.